For this question, I'm going to use both the what we call the forward substitution method and the backward substitution method to solve part 1 of the question. So, yeah. So the forward substitution method is always you starting from the defined number. So a sequence of positive numbers un is defined recursively as the first defined number in the sequence is u1. So you use from here you get u1 after that, and you do until you get the un. So that you can express in terms of this way. Un can be expressed, can be defined recursively as its relationship to the previous term, or it can define by itself. So we want to define by express as n. So that means we want to try to get this expression instead of based on this expression. So we start from u1 we know that equals to 2. So what is u2? u2 is just using this, is just half u1 plus 5, because when this is 2, when n is 2, n minus 1 is 1. So right, we know this relationship, right? And we go to u3 is just half u2 plus 5, isn't it? Okay, so now here we know that u1 is 2, so I need half times 2 plus 5. Okay, so I don't want to evaluate this, although I can evaluate to half times 2 is 1 plus 5 is 6, but it will not be helpful if you change this. So I'm going to use this part later. You see how I use this part. So for u2, I know that it is half times 2 plus 5, so I'm going to take half, then this part is my u2. I'm just going to slot it in here. Okay, u2, half u2 plus 5. I'm going to just take this part because this is my u2 and slot it in here. This is the method to do. I don't evaluate. Once I evaluate, I lose the pattern. The pattern that I'm going to show you is this half. Oh, sorry. The pattern is this half. When I multiply half inside, it will be half square times 2, okay, plus half times 5 plus 5. From here we can see, okay, a geometric series is developing, okay, and after u4 we can see the pattern after u4, but if you can't, I just go to u5 and show you. So let's say if I know that u4 is just half u3 plus 5 based on this recurrence equation here. So this one will be, what is my u3? Again, I know that my u3 is this entire thing, isn't it? So I'm going to put half and bracket, this is my u3 plus 5. I'm going to slot this entire thing inside, so you get half square times 2 plus half times 5 plus 5 inside here. So then when I evaluate, it will be half cube times 2 plus half square times 5 plus half times 5 plus 5. Okay, half cube times 2 plus half square times 5 plus half times 5 plus 5. So now you see that, okay, a geometric progression is developing. Just now was 2 terms, alright? First time was 1 term, 2 terms, and now we have 3 terms. This term is by itself. You see, this term is by itself. It has no relationship to the 555. It's the 2. So this term is always by itself. So then how do I form an expression in terms of when it comes to un? What would my expression be? So when this is 4, you see, when this is 4, this is 3. When this is 3, this is 2. So I know that when it is n, this must be my n minus 1. And 4 is 3, so 4 minus 1 give me 3. So this must be my n minus 1. And there will always be these 2. As you go on, there will always be this 2. So even for 1 is defined. So when 1 minus 1 is 0, this will become 1. So 2 will give me 2. But I still have the behind this part. So since I know that this is a geometric progression, okay, this is a geometric progression with number of terms is always equals to n minus 1. Why? Because you see 4, there is only 3 terms. If n, there will be n minus 1 terms. 3, there will be 2 terms here. So number of terms in this part of the series, just this part without including this, is n minus 1. Then my common ratio, what is my common ratio? For geometric progression is always multiplied by the previous term is multiplied by half, give you the next term. This term multiplied by half give you the next term. So the common ratio in this case is your half. Okay, and number of terms ratio and a. The first term is just 5. Okay, so we always need these 3 things, right? When you use the Sn formula, that means the sum to n terms formula for geometric progression, which is this thing is the number of terms, right? Don't confuse with the n over here. So number of terms equals to n, so a 1 minus r, and the n is also the number of terms, not the n over here. So over 1 minus r, you can rewrite it in terms of number of terms, this formula. Okay, so then we will have, in this case, therefore we must substitute n minus 1 into here, into the n. So n must be replaced by n minus 1. Okay, because there are only n minus 1 terms over here. So I will add the sum of this one. The first term again is 5. 1 minus common ratio is half. Number of terms is n minus 1. Okay, over 1 minus half. So this is just applying this formula from the geometric progression, right? So once I get these, so I'm going to simplify so that it gets to the form here. So 1 minus half is half. 5 divided by half is 10. So I have 10 times 1 minus half n minus 1, okay, plus 2 multiply to half n minus 1. So it will become half okay, I want this half n minus 1 because I see it here. So this would be, I just skip it. So 2 half n minus 1. So I want to prove to this result. That means, okay, this when I simplify, when I multiply in, okay, when I multiply in this, the first 10 times 1 will give me 10. Okay, so I'll change this to 10. Never mind, I rewrite out the full thing, just in case you get confused. Half n minus 1 plus 10 times 1 give me 10 minus 10 times half n minus 1. So this and this same. So 2 minus 10 is minus 8. Okay, half n minus 1 plus 10, which is this term is the same as this term, just that the order is changed. So then I have shown this part. So the next thing is to find the least n, where n is an element of positive integer such that un. So since I know this, okay, I'm going to erase all of this mixed space. Since I know this, the next step is just to sum up all this u1 to un. Okay, so I'm going to use the summation. This is applying your understanding of summation notation. Okay. Oh, I haven't shown you the backward method. The backward method is slightly different. So but never mind. I do this the backward method. Okay, the backward method, you start with un. Okay, you start with un being half un minus 1 plus 5. Okay, then you know that since equals to half, then un minus 1 is just un minus 2. Okay, so un minus 1 is just equals to what? Half times un minus 1 is just equals to half times un minus 2 plus 5. Okay, plus 5, then equals to half times So this one you might want to simplify first. Okay, at this step you might want to simplify first, so you get half square un minus 2 plus half times 5 plus 5. It is similar to the forward method, just that so I have half square the un minus 2. Personally, I prefer the forward method. They will always work. As long as one method works, the other method would work. So this one un minus 2 will be just equals to half un minus 3 plus 5. Okay, and so this would be half cube un minus 3. We are just simplifying this thing. So half cube, so that later the working is easier to do. So half cube un minus 3 plus half square times 5 plus half times 5 plus 5. So again, you see the geometric progression being developing here, and this term is always is coming out. So let's say if I go on to which term should I stop? I should stop when I hit the term that is defined, the u1. Once I reach this, then my expression would be simplified. There will no longer be the un minus something over here. It will become a number. So I must change it such that it goes to un minus what term? N minus 1. Because this term is just my n minus n is 0, so plus 1, so this will give me my u1. u1 is just 2. Right, so I want to reach this term. So before I do this, I leave it like this first, so it's easy for me to see what's the pattern. So I know that there will be a half, but I don't know what is this power, right? This power, you see, when 3 it is n minus 3, when 2 it is m when it is 2 it is m minus 2. I'm talking about the simplified form. Only look at the form that is after the simplification. So 2, there is a minus 2, so 3 is minus 3. So this is minus m minus 1, so the power must be m minus 1. And the number of terms, okay, you see at when this is 2, the number of terms here is 2. Okay, 5 and this one. So when this is 3, the number of terms here is 1, 2, 3 is 3. So that means when this is n minus 1, I expect that there will be a n minus 1 terms over here. Okay, the first term is always 5, 5, so it's still going to be 5 plus half times 5 and so on and so forth. So what is the term over here? The term over here would be, since this is 3 when this is 2, it is 2 when this is 1. Okay, so when this is n minus 1, that means this must be one term less. So this must be half n minus 2 times 5. Okay, so here we have this. I'm going to use a geometric progression to simplify this part also. Okay, so how to simplify this part? I know the geometric progression. Okay, this part I know. Okay, I've shift it to here. So from here equals to half to the power of n minus 1. Okay, this is just u1. u1 is just 2. Okay, and plus, so this part I will use the sum to n minus 1 term formula, because there are n minus 1 terms over here, equals to the first term is 5. Again, Sn, the formula is a 1 minus Rn over 1 minus R. So Sn minus 1, okay, a, still a, then 1 minus the R is the common ratio, but the n is changed to n minus 1, number of terms, over R minus 1, which is half. Okay, so top is 1 minus R, bottom must be 1 minus R, so 1 minus half as well. So then I simplify it to 1 minus half is just half. 5 divided by half is 5 times 2, so it's 10. 1 minus half n minus 1. So we're coming to the same conclusion as just now when we're using the forward method. So now we have equals to half m minus 1 times 2 plus 10 minus 10 times half m minus 1. So I get 2 minus 10 is minus 8 times half m minus 1 plus 10. So it's the same as the result earlier. So the key about this backward induction method is that you see this is m minus 1, this is m minus 2, this is m minus 3. We are going to progress until the, but where do we know when to stop? We must stop when the term here get to u1. Okay, and in order for that term to get to u1, this thing must be, you must choose it to be m minus 1 so that you get to u1, and then you analyze the relationship between this number and the rest of the numbers, and the numbers here, here, and here, here, and then you will get to express all of them in terms of n, and then you will be able to analyze that this part, number of terms in the geometric progression, and you apply the Sn formula. The same idea, you need to apply the Sn formula for geometric progression in the forward method as well. So I've done the forward and backward method. Now I'm going to find the I'm going to show you how to get the least n. So since we have already found the, okay, I'm going to show you how to get the least n. Okay, since summation n equals to 1n un. So what does this mean? Since we know that un is equals to this, so this is equals to finding n equals to 1, 10 minus 8 times half to the power of m minus 1. Okay, so this one, when it's a constant, it's just like 10 plus 10 plus 10 n times, so you should test 10n. Okay, because there are n terms in this series. So imagine you have this, so this is n equals to 1 plus, when n equals to 2 is still 10, when n equals to 3 is still 10. So when you add them up, how many terms will there? When you reach to n equals to n, you count 1, 2, 3, 4 all the way to n. So there are altogether n terms, correct? N of the 10 is 10n. Okay, if I change this to 2, then the answer will be different. If I change this bottom to 2, it will be m minus 1 times 10. Okay, if I change this to 3, it will be m minus 2 times 10, because the number of terms will change. Same thing if I change the top, you must count the number of terms in this series. In other words, the formula is n minus 1, top, the number top minus the number here, plus 1 times 10. Plus 1 is by default. If you want to count the number of terms in a series, right, just take the top number minus the bottom number, add to 1. So that will give you the number of terms in the series. Okay, and then you multiply to the constant. For constant, this is the way to deal with it. But I still have one more part, which is the series here. So minus 8 is a constant. I could bring out of the summation sign. Okay, and there will be a half m minus 1 over here, and this part, okay, what would this be? What would this part be? So I know that if this is half, this is a geometric half to a power of something, the n here, so this must be a geometric progression. If I show you geometric progression with ratio half, if I show you, you will understand. So 1 minus 1 is 0, so first term is so this part, I'm showing you this series. This series, the first term is 1, because 1 minus 1 is 0, half to the power of 0 is 1. Then plus, when n equals to 2, 2 minus 1 is 1, so plus half. Then when n equals to 3, 3 minus 1 is 2, so become plus half square. So on and so forth until it reaches the n minus 1, so I'll get half times m minus 1. But how many terms are there over here? So when it's 2, we have 3 terms. When it's 1, we have 2 terms. So when it's n minus 1, we have in total n terms. Okay, we can also see from here n minus 1 plus 1 is that all n terms in this series, and common ratio equals to half, and then the first term is just 1. So I can use the sum to n term formula again. I use Sn equals to a 1 minus r number of terms over 1 minus half. So then I will get to what? This is 1 minus half is half. 1 divided by half is 2. 1 minus half to the power of n. So then I will substitute this back into here, because what I'm trying to find is this, and this is equal to this. So then this is 1 minus half to the power of n. Right, in your exam, don't be stingy with space when you don't know how much working you need inside. So therefore, yes, this. Then after this, 8 times 2 is minus 8 times 2 is just minus 16. So we have this thing over here. It's quite simplified. Now we want to show, then since this one we want it to be greater than 500, and this thing we know that is equals to this thing. So you just need to solve for this. You just need to solve 10n minus 16 plus 16 times half to the power of n greater than 500. For this, you need the graphic calculator. Okay, you need the graphic calculator to solve this. You will plot the graph. Let's see if I have the graphic calculator ready. No, I don't have the graphic calculator ready, but what you do, okay, you use the graphic calculator and you do this. You set the window. You set the window from well, at y max. I know that the y max, since I want to find the intersection point at 500, I let the y max be 501 and y minimum be 499. So 500 is between. So then I will plot. Okay, when I press y equal, I will have y1 and y2. Alright. So then I will change the it should be in the function mode. Your calculator should be the function mode. Then y1 you key 10n minus 16 plus, actually this 16 can bring over, so instead minus 16, this could be 516. Okay, so you just key in the equation one, you just key 10n plus 16 and half to the power of n, and y2 I just key 516. If I key 500, that means I must change this y max to 517 and this one to 515, so I can see the intersection point. But what is my x min and x max for my window? This one is a bit of skew, so you don't know where exactly the x value, right, the x intersection point, right, would be the x coordinate would be the solution for your n. So I what do I do? So what you choose a range of values, maybe from 0 to x minimum. You choose from, since n must be a positive number and n must be greater or equals to 1, right? So, and you know that, okay, started from 2, u2 is not a very big number, so you change something to the x minimum. If you want a broad range, could change 20 to maybe 1000, for example. I don't think it will be such a large number. Or if you can't, you do 100, things like that, and you adjust. If you don't get an answer, you adjust again. So then you have to use the after that you use the graph. You graph, then you press second calculate to do the find the and 5 to find the intersection point. Then key enter 3 times. You should get x value. The x value you get in the calculator is your value of the n. So then if it is a decimal place like 3 like something point something, you just round up because you want the least value of n that's greater than that number. You want the number that's greater than that number. So whatever number you have, you round up to the next integer to get your n. Okay, so that's it for this tutorial.